every comet heading towards Earth explained. Because right now, 5 bright comets are approaching our planet, including an interstellar visitor traveling 137,000 miles per hour from another star system. We're witnessing Comet Lemon returning after 1,396 years, plus something that shouldn't exist, a CO2-rich comet from deep space with no water ice. But here's what keeps astrophysicists awake. Neil deGrasse Tyson calculated we'd have just months to respond if a long-period comet emerged from darkness. Today, I'll reveal which comet you can see with naked eyes this October, and why Earth's defense strategy remains dangerously theoretical. Let me paint you a picture that'll fundamentally change how you see the night sky. Right now, as you're watching this video in September 2025, we're experiencing something extraordinary. A convergence of cosmic visitors that's giving astronomers the kind of data they usually only dream about. And trust me, once you understand what's really happening up there, you'll never look at a clear night the same way again. Charles Liu, the astrophysicist who helped design the Rose Center for Earth and Space at the American Museum of Natural History, puts it brilliantly. We're not just observing space rocks. We're reading the autobiography of our solar system. Each comet carries chemical fingerprints from different epochs of cosmic history. Some formed alongside Earth 4.6 billion years ago, while others, and this is where it gets wild, predate our entire solar system. Think about that for a second. When you see a comet, you're not just seeing a pretty light in the sky. You're witnessing a time machine, a messenger from an era when the universe was younger, stranger, and following different rules. The 5 comets currently approaching Earth. They're like having 5 different history books flying toward us at ridiculous speeds, each one written in a language of ice, dust, and frozen gases that we're only now learning to read. Hold up, before we dive into the really terrifying stuff about impact scenarios, hit that subscribe button and ring the notification bell. I'll be tracking these comets in real time through October and November, and trust me, you don't want to miss the moment one of them potentially becomes visible to the naked eye. So, who exactly is showing up to this celestial party? Let's start with the headliner, Comet C/2025 A6, better known as Lemon. This isn't some random space rock. This is a periodic comet with a 1,396-year orbit that last graced our skies when the Byzantine Empire was inventing Greek fire and Islam was spreading across North Africa. The Mount Lemmon survey discovered it using a telescope with an absolutely bonkers 111 megapixel camera. And even with that technological marvel, they almost missed it. But Lemon is just the opening act. The real showstopper is 3 I/ATLAS, only the 3rd interstellar object humans have ever detected. This thing didn't form in our solar system. It's a genuine alien, born around another star, possibly billions of years ago. When astronomers at the Atlas telescope in Chile spotted it on July 1st, 2025, they knew immediately something was different. The trajectory was all wrong for a local comet. This visitor has been drifting between stars for eons, and by pure cosmic coincidence, it's passing through our neighborhood right when we have the technology to study it. Here's where the plot thickens. SphereX and the James Webb Space Telescope have been analyzing 3 I/ATLAS, and what they've found challenges everything we thought we knew about comet formation. This ancient traveler is rich in carbon dioxide ice, but shows 0 signs of water ice or carbon monoxide. For context, that's like finding a car with no engine or wheels. It shouldn't exist according to our models. Yet, there it is, screaming through space at velocities that make our fastest spacecraft look like they're standing still. Let's talk about velocity for a moment, because the numbers here are genuinely mind-bending. When 3 I/ATLAS was discovered, it was moving at approximately 137,000 miles per hour. To put that in perspective, if you could travel that fast, you'd circle Earth's equator in about 11 minutes. You could reach the moon in less than 2 hours. At that speed, a grain of sand would hit with the force of a bullet. But here's what makes interstellar objects particularly fascinating and terrifying. Their speed isn't just about raw velocity. Neil deGrasse Tyson explained this perfectly in his research on impact dynamics. Objects from within our solar system are like cars on a racetrack. They're all going roughly the same direction at similar speeds. But interstellar objects? They're driving the wrong way on the freeway. The relative velocity difference means their impact energy is exponentially higher than similar-sized local objects. Mark this down. October 21st, 2025. That's when Comet Lemon makes its closest approach to Earth at about 60 million miles. Now, I know what you're thinking. 60 million miles doesn't sound very close. But in astronomical terms, that's practically a near miss. For comparison, the Sun is 93 million miles away, so this comet will be passing closer than our nearest star. The exciting part, and the controversial part, is the brightness predictions. Some astronomers, including teams using the Japanese comet brightness models, suggest Lemon could reach magnitude 4 or 5. In plain English, that means you might be able to see it with your naked eye if you're away from city lights. Picture this. You're standing in a dark field, looking northwest after sunset toward the constellation Bodas. And there it is, a fuzzy star with a faint tail, visiting Earth for the first time since the year 629. But here's where professional astronomers start arguing. Other models suggest the comet might only reach magnitude 7.5, meaning you definitely need binoculars. Why the disagreement? Comets are basically dirty snowballs held together by frozen gases, and as they approach the sun, they can experience sudden outbursts. Chunks of ice suddenly sublimate, creating jets of gas that can brighten the comet dramatically and unpredictably. It's like trying to predict when a piece of dry ice will suddenly start smoking. There are too many variables. This is where things get genuinely historic. On October 3rd, 2025, interstellar Comet 3, I/ATLAS, will pass within 18 million miles of Mars. NASA has quietly mobilized every available asset on and around the red planet for observations. We're talking about the Perseverance rover, Curiosity rover, Mars Reconnaissance Orbiter, plus the European Space Agency's Mars Express and ExoMars Trace gas orbiter. Think about what this means. For the first time in human history, we'll have photographs of an object from another star system taken from the surface of another planet. A machine built by humans, sitting on Mars, will photograph a visitor from interstellar space. If that doesn't give you goosebumps, you might want to check if you still have a soul, but there's a deeper game being played here. These observations aren't just about scientific curiosity. Space agencies are using this as a live drill for planetary defense scenarios. How quickly can we mobilize observations? How accurately can we track trajectory changes? How well can multiple space assets coordinate? They're essentially wargaming our response to a potential threat, using a comet that poses zero danger as the test subject. Quick interruption. If you're finding this as fascinating and terrifying as I am, drop a comment below about what concerns you most. The detection gap for long-period comets, or our limited deflection capabilities? And share this with that friend who thinks asteroid movies exaggerate the danger. Spoiler alert, they actually underplay it. Now let's address the elephant in the room, or rather, the potential dinosaur killer in the sky. Charles Liu has spent years working on impact scenarios at the American Museum of Natural History, and the physics he describes should give everyone pause. When a comet or asteroid strikes Earth, the immediate effects are almost incomprehensible. The initial impact generates shock waves traveling at 70 times the speed of sound. The air itself becomes a weapon, compressed into a wall of superheated destruction. The energy release vaporizes the impactor and excavates a crater roughly 20 times its diameter. But that's just minute one of the apocalypse. Neil deGrasse Tyson calculated that the odds of dying from an asteroid or comet impact are roughly equivalent to dying in a plane crash. That sounds reassuring until you understand the math. Aviation kills about 100 people per year in accidents. Over 10 million years, that's a billion deaths. A single major impact could kill 1 billion people in one day, plus billions more in the following months from climate collapse, agricultural failure, and societal breakdown. Here's the part that keeps astronomers up at night, and I mean that literally. Long-period comets, the ones from the Oort cloud billions of miles away, are essentially invisible until they're already inbound. These objects spend most of their existence too far from the sun to reflect meaningful light. By the time they're bright enough to detect, we might have anywhere from a few months to perhaps 2 years to respond. Remember Comet Hyakutake in 1996? Discovered just 4 months before its closest solar approach, it passed within 10 million miles of Earth, a cosmic hair's breadth. Nobody saw it coming because its orbit was tilted way out of the solar system's plane. We were looking for threats along the ecliptic, the cosmic highway where most objects travel, while Hyakutake came at us from above, like a submarine attacking from below. The Vera C. Rubin Observatory, now operational, represents our best hope for early detection. It's expected to discover between 5 and 50 interstellar objects in the coming years. But here's the terrifying implication. If we're about to start finding dozens of these things, how many have already passed through undetected? How many near misses have we had without even knowing it? Let's be brutally honest about humanity's ability to stop an incoming comet. The DART mission in 2022 proved we could alter an asteroid's trajectory, a genuine achievement. But it also revealed something NASA doesn't advertise. The impact created an unpredictable cloud of debris. Some of those fragments could pose their own threats. It's like successfully dodging a cannonball, only to get hit by the shrapnel. The bigger issue is response time. With a long-period comet, we might have just months to act. In that time, we'd need to detect it, calculate its trajectory precisely, design a mission, build the spacecraft, launch it, and intercept the target. The entire Apollo program, from Kennedy's speech to moon landing, took 8 years. We'd have maybe 1 year, if we're lucky. Charles Liu puts it bluntly in his lectures. Our current defense strategy assumes we'll have years or decades of warning. For the comets we can track, that might be true. For the ones emerging from the darkness of the outer solar system, we're essentially hoping they miss. But here's the beautiful paradox that even Neil deGrasse Tyson acknowledges. The same processes that could end civilization also made it possible. Comets delivered water to early Earth. They brought organic molecules, the building blocks of life. Every glass of water you drink, every breath you take, contains atoms that traveled here, aboard comets billions of years ago. The technology we're developing to track these threats is revolutionizing astronomy. The same instruments searching for dangerous comets are discovering exoplanets, mapping dark matter, and unveiling the universe's deepest mysteries. The Mount Lemmon survey alone has discovered thousands of asteroids, dozens of comets, and contributed to our understanding of everything from stellar evolution to cosmology. So here's your practical guide to joining this cosmic drama. For Comet Lemmon, you'll need to be ready by mid-October. Get binoculars. 7x50 or 10x50 models are perfect and relatively affordable. Download Stellarium or a similar app to help you navigate the night sky. Find a location away from city lights. Even a 30-minute drive can make a huge difference. On the evening of October 21st, look northwest after sunset. Find Arcturus. It's the brightest star in that part of the sky, with an orange tint. Comet Lemmon should appear nearby as a fuzzy patch, possibly with a faint tail pointing away from the sun. You're literally seeing an object that won't return for almost 14 centuries. The last humans to see it lived in a world without electricity, antibiotics, or any understanding of what comets actually were. For 3I/ATLAS, you'll need a telescope, as it won't brighten enough for binocular observation. But knowing it's there, knowing it came from another star, makes it worth the effort to find a local astronomy club with decent equipment. Imagine telling your grandkids you saw an actual interstellar visitor with your own eyes. As we wrap up this cosmic journey, let me leave you with a thought that Charles Liu shared during one of his lectures at the Museum of Natural History. He said that studying comets isn't really about the comets themselves. It's about understanding our place in a universe that's simultaneously hostile and nurturing, random and ordered, terrifying and beautiful. Every comet approaching Earth tells a story. Some, like Lemon, are old friends returning after long journeys. Others, like 3I/ATLAS, are strangers from unimaginable distances, carrying secrets from alien suns. Together, they remind us that Earth isn't isolated. We're part of a vast, dynamic, sometimes dangerous cosmic ecosystem. The 5 comets currently approaching aren't harbingers of doom. They're teachers, showing us how solar systems form, how water and organic molecules spread through space, and yes, what threats we need to prepare for. They're forcing us to think beyond our planet, to develop technologies and cooperation strategies that might one day save our species. So here's what I want you to do. Don't just read about these comets online or watch videos like this one. Get outside, look up, use those binoculars, or find a telescope. Join your local astronomy club. Trust me, they're always thrilled to have new members, because every person watching the sky is part of humanity's early warning system. Share your observations online. Tag your photos. Create excitement about astronomy in your community. Because the more people care about space, the more resources we'll dedicate to understanding and protecting ourselves from cosmic threats. We're living in the golden age of comet discovery, and you can be part of it. If you've made it through this entire cosmic journey with me, you're clearly someone who appreciates the profound and the practical, the terrifying and the beautiful. So, subscribe to this channel. I'll be posting weekly updates on these approaching comets, including exact viewing coordinates and brightness updates. Hit that notification bell so you don't miss the moment one of them becomes visible. Share this video with anyone who's ever looked up at the night sky in wonder. Remember, we're not just passive observers of the cosmos. We're participants in an unfolding story that's been running for billions of years. These comets approaching Earth aren't just chunks of ice and rock. They're messengers from deep time, teachers from the void, and maybe, if we're smart enough to listen, the very things that save us from themselves. Keep looking up, stay curious, and remember, if you see something bright getting bigger in the sky, it's probably Venus. But maybe, just maybe, grab those binoculars just to be sure.